for today, we're just going to do the first half of this section. And so we're going to do just talking about how to solve exponential equations. Remember that when you solve equations, what you are doing is undoing operations because you're trying to get the variable isolated or by itself. And since in exponential equations, the reason it's an exponential equation is because the variable is the exponent, right? So in order to take care of that and to be able to solve for that exponent, we're going to have to be taking the log, because we talked about before in section 1 and 2 that an exponential function and a logarithmic function are inverses of each other. Go ahead. Now, the first type of exponential exponential equations that we're going to talk about are the very simple ones, where we can take the two sides of the equation and we can write it with like bases. If we can write it like bases, then we're going to use the theorem that says if b raised to the m is equal to b raised to the n, then m had to be equal to n. And we've used that idea already when we were evaluating some of our different exponents. So in checkpoint 1, they give us a couple here to do. Let's pull both of them up. And then part B. So like I say, this doesn't work for every exponential equation. It only works for these that have this particular form, the form where I can take both of these and write it to the same base. 125 is a power of 5, right? So I can rewrite this, and that's 5 to the 3x minus 6 is equal to 5 to the third, because 5 times 5 times 5 is 125. Since I can write it like this, this becomes a very simple problem, because we're going to use this theorem that says if I have a like bases and they're raised to do two different exponents, the only way that can be true is if what? The exponents are equal. So I can take this equation and say, okay, this is a true statement if and only if 3x minus 6 is equal to 3. It's the only way it works, right? Same basis, so my exponents have to be the same for this to be a true statement. And now I can just solve this little simple linear equation. So I'm going to add 6 to both sides. So 3x is equal to 9. Divide by 3. X is equal to 3. And then you can go back in and you can double check. Plug it back in. 3 times 3 is 9. Minus 6 gives me 3. And 5 to the third is 125. Any questions? That's the second way I'm going to show you all how to do these. Okay, we've got two different classification problems. We have this classification where we can make both sides be the same base, and then I'm going to show you the ones that can't. Only these special kind right here. There's not very many of them either. I'm just going to tell you right now. This is just a shortcut that only works for a very few problems. The other method I'm going to show you next works for everything. So even if you didn't notice that this was a one that you could do the shortcut on, it'll work with the other process. So you really don't have to remember this process. Sorry. Okay, so 8 is not a power of 4, right? Because 4 squared is 16. So obviously it can't be using 4 as my like base. What is my like base that I've got to be using? Not 8, because I can't take 8 and raise it to a power and get 4. We go smaller, y'all. We need a number that goes into both of these 2, right? So 8 is 2 to the third, and that 8 was raised to the x plus 2 power, so we got to write it that way. And 4 is 2 squared to x minus 3. Now, we could have used those other numbers that you said, but then I'd have had fractional powers, and I don't want them. I don't like fractions. Okay? So I'm not going to say that what y'all were saying wouldn't work, because we could have made it work, but we don't want to have to use fractions. Okay, so if you'll go underneath and get a smaller number to find a number that raised to a certain power gives you the base, then that's a better deal. Now, if I have one exponent raised to a second exponent, what operation do I use? Multiplication. So I've got 3 times x plus 2 is equal to 2 times x minus 3. So 2 is my base, and the exponents on 2, I said equal to each other. And then I can do the distributive property, because now I'm just doing this nice linear equation that we've been doing since 8th grade, right? Solve this. It gives me 3x plus 6 is equal to 2x minus 6. Then we have to subtract 6 from both sides. So 3x, this is a 0 pair, it's gone. 2x minus 12. Then I've got to subtract the 2x from both sides. Here, this is a 0 pair, so it's gone. So I'm left with 1x is equal to negative 12. So x is equal to negative 12. And then you go back and plug it into the equation to see if it gives you a true statement. Okay? Like I said, this is a shortcut, and it only works for problems of this particular type. I don't know about that. But, alright, so, now we need to talk about objective 2 is being able to solve using just logarithms. Okay, so we're going to talk about how we can do this using logarithms, and this method works for any exponential equation. So if you happen to not notice that there's one that you can do the shortcut on, this method is going to work. Okay? So the steps for this is, first of all, you isolate or get by itself the exponential expression. So in other words, you don't want a coefficient, you don't want anything added to it, you want it by itself on one side of the equal sign. Then we're actually going to take the log, and we're going to need to use base 10, or we're going to use the ln of both sides of the equation. Then we're going to simplify and solve for x. Okay, because what's going to happen when you take the ln is that you're going to be able to get rid of some stuff. Or take the log or the ln. It doesn't matter is what I'm saying. I usually do the ln of both sides because it's got 2 letters instead of 3. There is no reason to do one or the other. No advantage to do one or the other. Okay? So I just always do the ln. Left to right. That's right. Exactly. All right. So, checkpoint 2. So part A says 5 to the x is equal to 134. Part B, the second problem they want us to do there, is 10 to the x is equal to 8,000. Okay. So, first of all, do you see I've just got the base with the exponent by itself on the left-hand side there. So this is, number one's done for us. Step one is done. It's isolated by itself. Now, 5's not an e and it's not a 10. So there's no advantage. So I'm just going to take the ln of both sides. Okay, so this is the ln of 5 to the x is equal to the ln of 134. Okay, everybody see it? The ln of both sides is all I did. Now, this is where I'm going to use that property that so many of you tried to use on the test in the wrong place. But this is one of the reasons why we learn how to use those properties before we start talking about this, because this is the ln of something raised to a power. So what can I do with that exponent? I can bring it to the front and multiply it so that it becomes x is equal to the ln of 5. X times the ln of 5 is equal to the ln of 134. Okay? So we use the properties to simplify, so I don't have anything raised to exponents anymore, so that's what that simplify means. Okay? Simplify using the properties. And then now I can solve it, because how do I solve this for x? Divide by the ln of 5 on both sides. So you get x is equal to, and then since I use the ln or the log, whichever one you wrote down, you can just type in using the buttons on the calculator. So just hit the ln. Don't forget that it's going to open a parentheses, and it's not going to do it right if you don't close that off after the 134 and after the 5. 3.04? Does it round to 3.04? Okay, good deal. Okay. It does say find the solution set and use a calculator to obtain a decimal approximation to 2 decimal places. So that's as far as we need to go. Okay? Any questions about how to do that? That's the process. Now, you need to be thinking. You don't need to just memorize this process and just regardless do the same thing every time. You need to be evaluating what's going on, analyzing the situation, and choosing the method that causes the least work. I know y'all just called me lazy a minute ago, but it's called working smarter, not harder, right? We've got to think about what we're doing beforehand. Now, when you look at this, what is the base? So would I use the ln? Would I take the ln of both sides? That's crazy. I can take the log of both sides, because what's going to happen on this one? Log base 10 of 10 does what? It just cancels out and it becomes 1 times x, which is just x, whatever the log of 8,000 is. And so instead of having to type in 2 logs, if you're paying attention, you can just type in 1 and be done with it. 3.9, it's 2 places past the decimal. 3.90, thank you. Any questions about how to do that? It doesn't, and if you'd used the ln on this, you hadn't noticed that the log and 10 would cancel each other out. You'd have had the ln of 8,000 divided by the ln of 10. And look and see what that gives you. Same answer. That's why I say it doesn't matter which one you do, but if you'll pay attention, you can knock a step out of it if you're paying attention. Right. Side by 1. What is it? Did you make sure your parentheses are good? And did you, when you do the ln, you got to do the ln of 8,000 divided by the ln of 10, because you got to do the base. The base doesn't disappear on that one if you take the ln of it. DJ, what did you say about? Okay. It says, just as a side note, in many states, drivers under the age of 21 can lose their licenses for driving at that level. Okay? Sorry. All right. So, where does the 7 go? Okay, so let's look at our formula over here. X is the blood alcohol concentration, and R, given as a percent, is the risk of having a car accident. So it's just a 7. It's not written as a decimal. It's written as a percent. So it's just 7 is equal to E, 6 times E to the 12.77x. Okay? Normally, if I have a percent, I do have to put it in as a 0.0 unless they've given me the formula written that way. And it'll tell you. Okay? Are we good? Now, this becomes just one of those problems that we learned last time how to solve. How do we solve this? Get the E by itself, so what do we do first? Divide by the 6. So we got 7 over 6 is equal to E to the 12.77 times X. Now what do? Take the ln of both sides. So we got the ln of 7 over 6 is equal to the ln of E to the 12.77x. Now what do I have? That's right. These two cancel out, and I just have 12.77 times x is equal to the ln of 7 over 6, which is just a number, right? And then what do? Divide by that 12.77. Did Alexis go to sleep? Yes. They've been very quiet. Which is what? .012. Okay, that .01 that I was talking about. They pull you over and your alcohol levels of .01. They will haul you to jail. That kind of business, blood alcohol concentration has several factors to it, DJ. You really can't just say it's just one beer. It depends on the person's metabolism. It depends on how much you've had to eat. It depends on your body size. It depends on how fast you drank the alcohol. Like if you drank one drink over a period of 2 hours and didn't drink anything else, then your body will metabolize that alcohol and it won't still be in your bloodstream and it will be flushed out of your system. It's when you drink lots of drinks very quickly, or if you're a very small person like someone my size, if I drank, I couldn't get away with drinking hardly anything before I got into a vehicle because I just don't have a big enough body. I don't know why it's got something to do with your body size, but we do know that people's bodies metabolize the alcohol better if they're larger. Not heavy, but just, more bone, more muscle. It's like I guess because of the muscle, your body metabolizes stuff faster if you got more muscle. We know that. All right. Good thing is I don't have to worry about it, right? I don't drink. All right. Checkpoint 10, you're right. How long to the nearest tenth of a year, everybody hear that, to the 10th of a year, one place past the decimal, will it take $1,000 to grow to $3,600 at 8% annual interest if it's compounded quarterly? So first of all, it says compounded quarterly. So what did my formula look like? Okay, there's my formula. Now we've got to look back at our problem and see what did they give me. What is the 1,000? Nope, the P. What is the 3,600? That's the A. That's how much is going to be in the account at this time when I'm talking about. It's 8% annual interest, so that goes 0.08 in for R, and it's compounded quarterly, so what's in? 4. And we're looking for the time, so that needs to have a variable left in it. So now how am I going to solve this? Can't distribute. Going to divide by that 1,000. So I've got 3.6 is equal to you may see something else that I can do to make my life a little easier. What? Subtract 1. Can't subtract 1. It's inside the parentheses with being raised to the 4t power. I can figure what this is, right? So that's 1 point, and that's 0.02. Right? Now I got to do what? Anytime that my variable's in my exponent, I take the ln of both sides. So I'm going to do the ln of 3.6 is equal to the ln of 1.02 to the 4t. Now I'm using one of those properties that we learned in Section 3. What am I going to do? Bring the 4t to the front. So I've got the ln of 3.6 is equal to 4t times the ln of 1.02. Now what do I, if I'm going to solve it for t, what do I do? Everything's times t, so how do I get rid of it all? Divide by that stuff. So I'm going to divide by the 4 and the ln of 1.02. Yeah. What? So I just took this 4t right here and brought it down in front because that's my property that says if I'm taking the log of an argument and the argument's raised to an exponent, I can take the exponent down as a coefficient. Whatever that is. 16.17 years. And it wanted it to the nearest tenth of a year, so it's 16.2. So just a little bit more than 16 years. Yep, years. T is in years, remember my formula? Yep, you need to know that. Okay, and then of course we'll do an application problem with the log, so checkpoint 11. It's using the function that f of x is equal to 54.8 minus 12.3 times the ln of x, where f of x is the percentage of Americans who say that they're in fair or poor health, and x is their annual income in thousands of dollars. So if it was 1, then it's 1,000. Everybody understand when it says that? If it says the annual income in thousands of dollars. Okay? All right. So it says, according to this function, what annual income corresponds to 25% of Americans saying that they're in fair to poor health? So where does that go? And it is a percentage. It's giving it to you as a percentage. It goes with the f of x. So I'm going to put 25 is equal to 54.8 minus 12.3 times the ln of x. And then once you figure out where to put the thing, then you just start doing our process for solving a log problem. Go subtract the 54.8. Anybody done that yet? 18.2, negative 18.2. Jeez, I'm good. Alright. And then go divide by that negative 12.3. So we are back to a positive number. The ln of x is equal to whatever that is. It's more than 2. 2.42. And then how do I solve this when it's an ln? You use e. So the base, which is e, raised to the answer, is equal to the argument. Y'all got to learn how to use that formula. The base of ln is e. E to the answer of the log problem is equal to the argument. No, that's just a number. You just plug that in. 11.0. So 11,000. $11,200. So about $11,200 is their annual income. Oh, we're out. You have to use my paper towels over there. Sorry, I'm out. They're like that's the thing. Yep. Not good, period. All right. So page 467, you're going to do 50 through 90 evens. And then the application problems I want you to do are 102 and 116. Huh? I've already given it to you? Good. Just couldn't remember if I had or not. I am going to show you some more complicated ones. These are very, very simple, and we're going to do some more that have more steps to it. If you had done the ln with this, you'd have the ln of 10 to the x is equal to the ln of 8,000. Bring this down. So it's x times the ln of 10 is equal to the ln of 8,000. And divide both sides by the ln of 10. We good? No? The next one that we're supposed to be doing is we're supposed to be solving this equation. 7e to the 2x minus 5 is equal to 58. On the other two problems that we did, remember that step 1 was done for us. The exponential part of the function was by itself. Here, first of all, I need you to tell me what is the exponential part of this function. have to take the base with it. So it's not just the 2x, it's the e to the 2x. Not the 7, just the e to the 2x. Because without it, the exponent doesn't make any sense. Okay, so this is my exponential part of this expression. Okay, that's the part that needs to be sitting by itself before I take the log of both sides. Okay, so what's my step number 1 going to be? Add the 5 to both sides. Gives me a 0 pair, so this is 7 times e to the 2x is equal to 63. Now I got to divide by the 7. So e to the 2x is equal to 9. And now you're stuck. Somebody want to tell me whether I'm going to do the ln or the log? The ln, because my base is e, because it'll cancel out. You can't move the exponent. Before you start moving anything, you have to have taken the log or the ln of it. Okay, you can't use that property until you're working with the log. That property only works for logs. So we got to take the log of both sides first, and then I can move that 2x down. But I don't necessarily have to this time, because what do I know about the ln and e? They cancel out, and this just becomes 2x is equal to the ln of 9. And then divide by the 2. So x is equal to whatever the ln of 9 divided by 2 gives you. Did you make sure and close off your parentheses behind the 9? .09? Okay, good deal. Are we good here? Everybody got this? Okay. Next example. Checkpoint 4 says we want to solve this equation. 3 to the 2x minus 1 is equal to 7 to the x minus 1 plus 1. Oh my goodness. I can't move anything because they're both exponential expressions, right? Just take the log of them then. Okay? So let's do the ln of 3 to the 2x minus 1 is equal to the ln of 7 to the x plus 1. I'm just going to take the ln of both sides since I really can't move anything around. I got exponents on both sides. Now what do I do after I take the ln of both sides? I can take those exponents down. So I've got 2x minus 1 times the ln of 3 is equal to x plus 1 times the ln of 7. The thing I want you to kind of keep firmly in mind here is the ln of a number is just a number. Okay? So it's like having a coefficient. So I'm going to take that ln of 3 and I'm going to distribute through my parentheses. It's just like it was a number. So I've got 2x times the ln of 3 minus the ln of 3. Everybody see it? Let's do the 2x times the ln of 3 and the 1 times the ln of 3. Then I got to do the same thing on the other side. So I've got x times the ln of 7 plus the ln of 7. No, because, okay, not like terms. Now, just like every other time when I'm trying to solve for x, I got to get everything that's got an x on one side and everything without x's on the other side. So the minus ln of 3 needs to come across, right? So I'm going to do that by adding the ln of 3 to both sides. And I don't have any like terms, so it's just going to get listed over there. So I'm going to have 2x times the ln of 3 is equal to x times the ln of 7 plus the ln of 7 plus the ln of 3. That's exactly right, DJ. That one that's got the x in on this side, I need to subtract it from both sides. Again, those aren't like terms. I can't combine them together, so I just got to list them. That's 2x times the ln of 3 minus x times the ln of 7 is equal to the ln of 7 plus the ln of 3, because that's a zero pair and it's gone now. Now I have it sorted. Yep. Nope. All non-like terms. I just got to list them all. Pretty much. Now, this is the trick, and it comes up a lot in every other math class that you might possibly have to go into past this, except statistics. This doesn't use any algebra. If you have the variable in more than one place, then what you try to do is you try to factor the variable out. So if I pull the x out in front, then what's left out of this term? 2 ln of 3. There's my minus sign. If I factor my x out of here, what's left? The ln of 7. And then, of course, I'm not doing anything to the other side, so I just got to write it down. Now I've got x times that thing, so I can just divide by that thing. It's kind of ugly, but I can still divide by it, right? So that'll get it on over there. The only thing that becomes a problem is you do have to be very careful when you put this in your calculator to try to make sure that you have the correct answer. So you're going to need a parentheses so that for the whole top here. So you've got the ln. It's going to give you a parentheses. Close that off. Plus the ln, it'll give you that parentheses. So do your 3 and close that off, and then close off the top. So you got lots of parentheses that you have to use when you type this in. Okay? Then you're going to divide that, and you got to have another parentheses. Anytime you've got more than one term in the top or the bottom, you got to put parentheses around the whole thing. You're going to put your 2 and your ln. It'll open that parentheses, close it off after the 3, type in your ln again, close off after 7, and close off the bottom. If you type it in that way, then you're going to get the answer to that expression. Is that what y'all got? 12.11. Let me check it.
I put in parentheses for the top and for all of the 3.
Checkpoint what? 4? 12.11. Alright. There's one more type of equation where you might have these exponentials. There's another process that you're going to need to do. This is in checkpoint 5. I'm hoping at this point that when you look at this, you see you got how many terms? 3, right? 3 terms on the left-hand side. That's called a trinomial. And I'm hoping at this point that you are noticing that you've got an e to the 1x and an e to the 2x. That's an x. Checkpoint 5 is in your book. You can look. This we're going to do with a U substitution because this is a quadratic type equation. Remember when we did all of these in Chapter 3? Same idea here. If we let U be equal e to the x, then U squared is e to the x squared, right? Isn't it? If I square one side, I got to square the other. But if I've got something, a base that's being raised to two different powers, what do I do to the powers? Multiply them together. So this is the same thing as e to the 2x. Do you agree with that? Okay, so in your equation over here, everywhere you see e to the x, you're going to replace it with a u. And everywhere you see e to the 2x, you're going to replace it with u squared. So I come back over here, e to the 2x, u squared, minus, there's an 8, and e to the x replaced with u, plus 7 equals 0. So now, is it easier to see this is a quadratic type equation? Because now that's just something that I can factor very easily, right? How about u minus 7, u minus 1? Does that not multiply together to give me positive 7 and add together to give me negative 8? Okay, so that means then, what do I do to solve this equation? I take each factor and set it equal to 0. So u minus 7 is equal to 0, and u minus 1 is equal to 0. So u is equal to 7, and u is equal to 1. Now, we're not finished with this problem, right? Because anytime I do this u substitution thing, what do I have to do? Switch it back. So u is the same thing as e to the x, right? So e to the x is 7, and e to the x is 1. Now, what do I do with this? Take the ln of both sides, right? Yes? Right? Because I'm just back to one of these problems that I started with originally, one of those nice easy ones at the beginning, right? And the ln and the e cancel out, and so I just get x is equal to the ln of 7, whatever that is. And now I take the ln of both sides here. So x is equal to the ln of 1. So if you want decimal approximations, what's the ln of 7? And what's the ln of 1? What? 0? Hey, are you sure it's 0? Why is it 0? Because anything to the 0 power is 1. So the only way that we get e to the x being 1 is if x was 0, right? Hopefully, when you saw this, you knew x was 0. Right? Don't have to take the ln both sides? Y'all knew that. All right. That's all there is on that first section. That's plenty. Okay. So, the idea here that you want to do is you've got to get this so that it's just a single log before you can do the piece of it that is new. So, on checkpoint 6, we got the log base 2 of x minus 4 is equal to 3. Now, it's just a single log, right? Everybody see it's just a single log? One log, written one time. So the way that you solve this problem is that you take it completely out of the log process. Okay? In other words, that part of the test that we did, and some of you didn't do so hot on this, so y'all may need to practice this, is we're going to use the definition of logs, and we're going to rewrite this as an exponential equation. Okay? So it says to us that the base, which is 2, raised to the answer to a log problem, which is 3, is equal to the argument x minus 4. The base raised to the answer of the log problem is going to be equal to the argument of the log problem. So that's exactly right, because 2 to the third is 8. We can add 4 to both sides. X is equal to 12. Okay? Any questions about how to do that? Simple enough. But some of you didn't have a very good grasp of that definition, and you didn't do a very good job of rewriting things out of the log form into the exponential form. The argument, the thing that I'm taking the log of. Okay, look at B. We've got 4 times the ln of 3x is equal to 8. Now, just like before, this works just a whole lot better if I go ahead and solve this so that I don't have any coefficients or anything added on. I just want it with the log on one side, like I did with the exponent earlier. So the first thing I want to do is what? Get that 4 over there. So I'm going to divide by 4. So I've got the ln of 3x is equal to 2. Now, the problem with this one that some people seem to forget a little bit is what is my base when it's an ln? E. It's E. So E to the answer, which is 2, is equal to the argument, which is 3x. Remember, E is just a number. So to solve this for x, you're going to divide by 3. And if you'll hit your E button, and then you just raise it to the second power, get that answer, and then divide by 3. And you'll get an approximate answer because E is an irrational number, 2.46. What? Hmm. Right, so the base is E, so I take the base, I raise it to the answer of the log problem, which is the 2, and that's equal to the argument, the thing I'm taking the ln or the log of. Okay, it's the definition. You've got to memorize it. You've got to practice it. Like I say, a lot of you missed those problems on that test. Anybody else got a question? I mean, I know that y'all had problems with that. I saw it. So I'm just telling you right now, practice, practice, practice on that. Maybe go back to section 3 and look at those ones where it said rewrite in exponential form and do those problems and practice them. Because that's going to mess y'all up on this if you don't know how to do it. Checkpoint 7 is the exact same idea. We just got to do a little bit more to this one because it says to solve this equation. It says the log of x plus the log of x minus 3 is equal to 1. We cannot do that definition idea until I have this so that it's just one log. And I've got log written how many times in this problem? Twice. So I'm going to use the property of logs that was in section 3 that we worked on. And I'm going to rewrite this as just a single log. So what do I do to the 2 arguments? I multiply them together. So this is the log of x times x minus 3 is equal to 1. Okay? So the base, which is 10, raised to the answer, which is 1, is equal to the argument, which is x times x minus 3. And you can write it the other way. You can put the argument first, and then if you like having your x's over on the left-hand side, doesn't really matter, right? If you like it better, you can write it like that. And so that's x squared minus 3x minus 10, right? Because I'm going to subtract 10 from both sides. Why did I subtract the 10? Because I saw it was a quadratic equation, right? How do I solve quadratic equations? Have to set them equal to 0 first, and then I can either factor them or I can put them in the quadratic formula, right? This one factors. X minus 5, x plus 2. So x is equal to positive 5 and x is equal to a negative 2 are my 2 solutions. Now, you do need to be careful when you do this. Because we can't take the log of any number, right? Somebody asked me a while ago, and y'all had it on the quiz just a second ago, what happens if you try to take the log of a negative number? It doesn't work. It gives you an error. It is undefined. You can only take the log of positive numbers. So you do need to go back and double check in your original problem before you started working it and make sure all of these answers that you got correct, because the word is extraneous. We do sometimes get something called extraneous roots, right? We didn't do anything wrong with the algebra as we were solving it, but it doesn't work back into the original problem because it's outside of our domain. So that negative 2 is going to give me issues. It's going to give me the log of a negative number and the log of a negative number. So that is not a solution. We have to throw it away. So the only answer that I get here is x is equal to 5. Okay? So just be real careful about that because, you know, that's outside the domain. If I'm working with logs, I can't have negative arguments. I can have a negative number for x as long as when I plug it back into the argument, it gives me something that's positive. Okay? All right. Now, then you get an empty set. Yep, that's exactly right. Check point 8 is ln of x minus 3 is equal to the ln of 7x minus 23 minus the ln of x plus 1. So now I've got 3 ln's. And I've got ln's on both sides of the equation. That's actually kind of a good thing. I'll show you why. What you want to do is just simplify on each side of the equation if you have ln's on both sides. So this side we're going to leave alone. It's the ln of x minus 3. On this side it's going to become the ln of 7x minus 23 over x plus 1. Right? Because it was a subtraction. And so what do I do with my arguments? I divide them. Now, you remember that shortcut method that we had with exponents where if it was a like base and it was being raised to the same power, I could just take the powers and set them equal to each other? Look here. Same logs. So I can just take the arguments and set them equal to each other. That's the one-to-one property that we had that said if the ln of something is equal to the ln of something else. Said if the ln of A is equal to the ln of B. The only way that's true is if A is equal to B. That's what all right, I used M and N. But what I'm saying here is if it's true that these are equal, the only way that's going to happen is if these two arguments are equal. Okay? So you can just throw away the ln part, kind of. And then I can work with just this and solve this for x. Okay? So, like Aaliyah said, if I have this side the fraction, I can always just multiply by the denominator, right? So if I multiply both sides by x plus 1, I get this. And then I get through FOIL, I'm going to get x squared minus 3x plus x minus 3. So combining like terms, I get x squared minus 2x minus 3 equals 7x minus 23. Now, how am I going to go about trying to solve that? Everything has to be on one side. So I'm going to subtract the 7x first. And what else? Add the 23. So I get x squared minus 9x plus 20 equals 0. So that all zeroed out. That one factors, right? Can y'all tell me what the factors are for it? You didn't think so. For it to be positive 20, they both got to be negative or they both got to be positive? Negative 4 and negative 5. So x equals 4 and x equals 5 are my two solutions from the process. Now what do I have to do? Double check back in the original equation. Will 5 work? Yes. And will 4 work? Yes. So I get two solutions. Because remember, all you're trying to do is look to see if it's a positive number. You can double check and make sure that it gives you a true statement, but it will. Unless you think you did something wrong with your algebra, that's a good way to check to see if you type something in your calculator wrong or whatever. If you plug it back into the original equation, it should give you a true statement. Okay? So any questions about how to do logs? That's all there is to it. You either use the definition, or if you get lucky and there's a log on both sides, then you can just pull the arguments down and work with them. But the first thing you have to do is you have to get it so that there's just one log on each side of the equation. Okay? Any questions? All right. And then there's only one thing left in this. There's some application problems. You wouldn't learn how to do this if there wasn't a real-world application for it. So checkpoint 9 tells us that we got a formula in example 9 that we need to use, and my formula is here. Okay. This is medical research has told us that the risk of having a car accident increases exponentially as the concentration in the blood the concentration of alcohol in your blood increases. That's where they get those limits, like if you've got 0.01, when they pull you over and they check your blood alcohol content, and it's more than a certain amount, you get a ticket for driving drunk, and if it's more than a certain amount, you just get hauled to the police station because they don't allow you to drive any further. That's where that comes from, is from this medical research that shows how much it changes your ability to make good judgments and to stop fast enough and to keep from having accidents. And that's the formula. That the risk that's involved and how likely you are to have an accident is equal to 6 times e raised to 12.77 times the concentration of the alcohol in your blood. Okay? So, on checkpoint 9, it says we're going to use that formula to answer this question. What blood alcohol concentration corresponds to a 7% risk of a car accident?